So we go to the question number 1, which is a question of 2013, June 2013. Question number 1. Bahatisha Limited currently manufactures a single product branded Z. Due to stiff competition in the industry, the company plans to launch additional products in the market. The production director has identified 3 products which are mutually exclusive, namely A, B, and C. The production director believes that demand for the products would vary depending on competitor reaction as follows. So we have that. The net present value for each of the possible outcomes is as given there. Perfecto Limited, a market research company, believes that it can provide perfect information on potential competitor reaction in this market. The company will use the expected value approach to make the decision. Required, advise the management on the maximum amount that should be paid for the information from Perfecto Limited. That should be paid. So the question is June 2013, question 1. The question is from decision theory. Decision theory, specifically what we call single stage. Specifically what we call single stage. Now, in this one, we have 3 options. We have product A, product B, and product C. Then here we will have the probability. The outcomes are strong. We have normal. We have weak, and then we have EMV. Then we have EMV. So this is what we call the payoff table. The payoff table is what we call the payoff table. So these ones, for product A, when it is strong is 360. When it is normal is 540. When it is weak, we have 900. Product B, strong is 720. Normal is 1080. And weak is 1440. Product C, strong is 1080. Normal is 720. And this one is 900. The probability of strong is 0.3. Normal is 0.2. And this is 0.5. That is 0.5. Have you finished drawing? Okay, yes. Okay, so now the first thing is most likely event rule. Most likely event rule. If you are using most likely event rule, you begin by checking whether the names are similar. Now, in this case, the names are not similar, so it is not applicable. So, most likely event rule, you say not applicable, since names of options and outcomes are not similar. Since the names of options and outcomes are not similar. But if they were to be similar, what you would have done, because you can see it's called most likely, you pick the probability that is the highest, this one. When you have this highest probability, you identify its name here, weak. So if there was an option called weak, you would have picked that. But now for this one, it is not there. The next rule that you will easily come across, is called the expected monetary value rule. The expected monetary value rule. So in using this, we have the option here, and then we compute the expected monetary value. We compute the expected monetary value. We compute the expected monetary value. So let's start with A. When we go to A, you will take 360 multiplied by 0.3 plus 540 multiplied by 0.2 plus 900 multiplied by 0.5. So give me that answer. And as we said, I need several answers. Yeah, I have one answer. I need several. Yeah, good. Those are enough. 6, 6, 6. Let's go to B. Let us go to B. You do the same thing. 720 times 0.3 plus 1080 times 0.2 plus 1440 times 0.5. I have one answer. Yeah, good, good. They are coming. 1152. 1152. Then let's go to C. C, I have 1080 multiplied by 0.3 plus 720 multiplied by 0.2 plus 900 multiplied by 0.5. One answer has come in. 2. Yeah, good. 918. So those figures, Kwanza, you can copy them here. You can copy them here. That way. Then, based on that, now you offer the advice. The advice. The advice, we go for the highest. The highest of this is this. So, the question was saying what? It was about the information that should be paid, but they are trying to launch additional products. So we will advise them to launch product B. Launch product B. That is what we shall advise them to do. That is what we shall advise them to do. The next one, the next rule that I want to remind you is called max rule. Max rule. Now, in this max rule, we have the option here, and then we take maximum payoff. Max rule, it says you take the option. So the option A, B, and C, you go to A, the maximum value in A, ukikibia through A, the maximum is what? The maximum payoff in A. Yeah, 900, good. That's the one we take. The maximum in B, P3 group B. $11.40, good. $11.40. And the maximum in C is 1080. 1080. So this one says you take the option with the maximum of the maximums. So the maximum of the maximums is this one. So again, the advice that we shall render to these people is that they should launch product B. They should launch product B. That is the advice that we shall provide to them. That is the advice that we shall provide to them. The next rule is called Maximin rule. So this rule requires you take the option here and then now you extract the minimum payoff. You extract the minimum payoff. So for A, the minimum is what? Let me see what is the minimum. Yeah, 360, good. B, the minimum is 720, good. C, the minimum is 720 also. 720. So the advice, now this rule states you take the maximum of the minimums. The maximum of the minimums. So the maximum happens to be 2, so you advise them to launch A or rather B or C. You advise them to launch B or C because they happen to have the same EMV, the same minimum. Then from there, the next rule is called Rapri's rule. Rapri's rule. So with Rapri's rule, we compute something called simple average payoff. Simple average payoff. Simple average payoff. So starting with A, you take 360 plus 540 plus 900. You divide by 3. You divide by 3 because there are 3 outcomes. You divide by 3 because there are 3 outcomes. $600. Abraham, you use the rule that has been asked. In some cases, they will just ask one. In some cases, they will ask several. So you use the one they have asked. But for me now, I want to take you through all of them that you can come across. Is that okay, Abraham? Ibrahim. B, 720 plus 1080 plus 1440. You divide by 3. Yeah, good. For now, I'm quickly reminding you of all this. What is the answer? Yeah, I can see one response. Yeah, good. 1080. 1080. Let us go to C and do the same thing. 1080 plus 720 plus 900. You divide again by 3. You divide by 3. Yeah, good. I can see many coming. So when you are using the Laplace rule, if we are told to use the Laplace rule, we go for the highest. So we go for this. So the advice down there, advise them to launch product B. Advise them to launch product B. And it's only a coincidence that the rules we have used so far, they are pointing to B. So don't cram that all of them give the same answer. No. It's only a coincidence, this question. The next one, inaitwa Howick's rule. Howick's rule. Now, Howick's rule requires something called alpha. So we can assume, when you see the word red, that means it has been assumed. It has been assumed. So this one, what you do, you get the option here. Then you get this alpha times the best payoff, plus 1 minus alpha times the worst payoff, and you get something we call weighted average payoff. Weighted average payoff. Weighted average payoff. You get weighted average payoff. So now, for option A, you take alpha, and I've said that has been assumed, but in an exam, they will have given you. In an exam, if they want you to use Howick's, they will have given you the rule, the value. So sasa, utasema 0.8 times the best payoff. The best payoff hapa kwa A ni 900 plus 1 minus, that should be 0.2. That should be 0.2 times the worst. The worst happened in 360. The worst is 360. The worst is 360. That gives us what? Have one answer. 792. Good. 792. Then we go to B. 0.8 times the best. The best there is 1440 plus 0.2 times the worst. The worst there is 720. The worst there is 720. 720. $12.96. I have one answer. Yeah, good. $12.96. We got to C. C, I have 0.8 times the best there. The best is then 80 plus 0.2 times the worst. The worst there is 720 again. Yeah, I can see the answer, 1008. So again, there you go for the highest, and that happens to be B. So the advice is they should launch. They should launch product B. Remember, I said it's only a coincidence that so far those rules appear to point to one product. The next one is Savage rule. It's called Savage. Some people call it regret rule. Regret rule. Savage or regret rule. Now this one requires that you create it requires that you create what we call the opportunity losses table. The opportunity losses table. So the opportunity losses table is created like this. We have A, B, C. Then we have the probability. So design mpaka hapo, taenda tukifunga column, taenda tukifunga depending on the space that is required. We are already there. So this is what you do in making the opportunity losses. You go to each outcome, you pick the highest. So the highest here is 1080. 1080. Then you subtract the others from 1080. So you subtract the others. So 1080 minus 360, what do you get? minus 360, what do you get? Yeah, 720, good. These are the one. 1080 minus 720. 360, good. At 1080 minus 1080, that is 0, and the probability is 0.3. So that is how you get the opportunity losses. We go now to the next one, normal. Ukifika kwa normal, again unachukua the highest. The highest is 1080. The highest is 1080. Then you start subtracting the others. 540, 1080, and 720. So tell me, 1080 minus 540, what is it? $540, good. This must be 0. Then this must be 360. And the probability is 0.2. Probability is 0.2. Then the issue of weak, the highest there is 1440. 1440. You minus the others, which are 900. 1440 and also 900. So this one must be 540, then 0 and 540 with a probability of 0.5. 0.5. Then you compute what we call the expected opportunity loss. Expected opportunity loss, you just get it like we got the EMV. So this one we are not going to write, just take the calc and we go together. So the same as 720 times 0.3 plus 540 times 0.2 plus 540 times 0.5. Give me the answer. When you multiply this with the probabilities as you add, yeah, good, 594. 594. Let's go to the next one. 360 times 0.3. Hizo zingine zote ni zeros. So the answer is 108. The answer is 108. Then hii ingine itakuwa 360 times 0.2 plus 540 times 0.5. That is 342. So here we pick the smallest. We pick the smallest. So the advice again is that they should launch. They should launch product B. They should launch product B. And if they had asked you to get the value of information, this is also the value of information. That one weighs the value of information. So kama ushatengeneza hii table and they are now asking for the value of information, you don't have to compute. Unachukua the lowest. The lowest UL is the value of information. The lowest UL is the value of information. Alternatively, Alternatively, value of information. If they require value of information and you have not prepared the table, like now what this question had required initially, you just need this original table. And when you get there, you take the highest in each outcome. So the highest here is 1080 multiplied by 0.3 plus the highest here is also 1080 multiplied by 0.2 plus hapa, the highest is 1440 multiplied by 0.5. Then you minus the highest EMV. You minus the highest EMV, and when you do that, the answer should be 108. Confirm. If it is 108, say yes. If it is 108, you say yes. Okay, good. So the next agenda is June 2005, question 1. Now that June 2005 is coming from regression and correlation theory. That is where it's coming from. That's where it's coming from. So we can read through the question. Tony Kichumi, a financial analyst at Green City Bus Company, is examining the behavior of the company's monthly transport costs for budgeting purposes. The transport costs are a sum of two types of costs: operating costs such as fuel and labor, maintenance costs such as overhaul of engines and spraying. Kichumi collects monthly data on items 1 and 2 above and the distance covered by the buses. Monthly observations for the year ended at 1st of December 2004 were as follows. So we have the month, we have the operating cost, we have the maintenance cost, we have the distance covered in kilometers. Now Kichumi ran 3 linear regression equations based on the data above and came up with the following results. Regression 1 is that the operating cost is A plus BX, BD. We have the variable, we have the coefficient, standard error, and t-value, R square, Durban-Waston statistic. Then the regression equation, we have the maintenance cost being equal to A plus BD. Then regression equation 3. Then we have the variables there. And now you are told to evaluate the 3 linear regression equations using economic plausibility. And then those are the things. So let's So the first thing, I want us to draw a table. Organize a very big table like this. And we call it reliability tests. Reliability tests. So we have details here. We have equation 1. We have equation 2. We have equation 3. Question 3. Have you drawn? Okay, good. Now, when you're doing the reliability test, there are some basics that you need to establish. One is the dependent variable. Dependent variable. Now, dependent variable in equation 1 is the operating cost. In equation 2, it is the maintenance cost. In equation 3, it is total transport costs. That is the dependent variable. Why? The second basic that you need to establish is the independent variable. Independent variable in that equation. In equation 1, the independent variable is distance. Distance covered. The same case with equation 2. It is also distance. And then it is also distance in equation 3. Equation 3. The other thing that you need to establish is the equation itself. Is the equation. The equation, you get it from what you can see there. It is y is equals to 309.19 plus 0.054 B. Then this other one, y is equal to 531.55 minus 0.031 B. Then here, y is equals to 840.73 plus 0.023 D. That is how you pick the equations. That is how you pick the equations. Those are the basics. Those are the basics that will help us do our reliability tests. I hope you are able to see where those things are coming from. So if we are okay with that, let us now start the tests. The first test that we are told to do is called economic plausibility. Economic plausibility. Economic plausibility. Now, economic plausibility, as you check later on in your notes, it simply checks whether the relationship is in agreement with what you would expect. So there are three things that you do. One is the expected relationship. You identify the expected relationship. Just to remind you, there are three types of relationships. One is called direct. And direct is where the two variables change towards the same direction and is represented by positive sign. Number two, inaitwa inverse. Inverse is where the variables change towards opposite directions and is represented by a negative sign. Now, relationship is number three. That is where they have no relationship and is represented by 0. Okay, so I want you to tell me what kind of a relationship would you expect between operating cost and difference? What kind of a relationship would you expect? Now, the person who joined the class with the name Just Felix, we are not able to find your name in the register. Please use your full names as per the registration. Okay, I can see the answers coming. We are expecting a direct relationship. We are expecting a direct relationship. So sasa hapa andika direct. Kuja hapa. What would you expect between maintenance and distance? What kind of a relationship? Direct, inverse, or null? Emmanuel is saying inverse. That means as you cover more distance, the maintenance goes down. Ibrahim, the same thing. As your vehicle covers more kilometers, you require to maintain it less. That's what you're saying when you say inverse. Someone else? Ivan says direct. That is that you cover more kilometers, you require more maintenances. That's what Ivan is saying. Hey, what would you expect? What would you expect? This one we would also expect direct. As the vehicle covers more kilometers, you require to maintain it more. What would you expect between total transport cost and distance? So Emmanuel and Ibrahim, I hope you have gotten that. Even Emily. What would you expect between transport and distance? It is also direct. Good. As you do more kilometers, the transport cost goes down. Now that is what you would expect. You would expect. Now the next thing is the observed relationship. Observed relationship. Now the observed is what you have seen. Is what you have seen. So here, which relationship is this? Which relationship is this? Yeah, this is direct because it is positive. Which relationship is this? It is inverse, good, because it is negative. And which relationship is this? Direct, good. Then from there, you make the conclusion. Conclusion, you either tell us whether it is plausible or not. And it is plausible if they're in agreement. So are these two in agreement? What we expected, is it what we have seen? Yeah, so if yes, that relationship is economically plausible. So Nadika plausible. This one, what we expected, is it what we have seen? What we expected, is it what we have seen? Good, so not plausible. This one, what we expected, is it what we have seen? So that is plausible. That is how you test economic plausibility. Economic plausibility. Let us now go to the next one. Goodness of fit tests. Goodness of fit tests. Goodness of fit tests. So wewe unaendelea na tempo hapo chini, mine is not endelea hapo. So I have to delete. So the next area that we are taught to test or to comment about is goodness of fit tests. Goodness of fit tests. Now, goodness of fit tests, it has very many tests. It has 6 tests. So the first test under the goodness of fit is R square. R square, the coefficient of determination, which shows us whether, or rather the extent of changes in Y that are explained by X. So can you see R square in our reports? In these results, have they given us R square? Can you see it? Equation 1, kama unaiona equation 1 iko na what? Equation 1 iko na what value? Yeah, 61. So you can make it 61%. Equation 2 iko na 68%. Equation 3 iko na 29%. That is regarding R square. Now this one, there are three ways. There are two ways in which you can respond. The first way, you can say this is the average, this is the highest, this is the lowest. Or you can tell us whether to accept or to reject. I told you a relationship that is below 60% should be rejected. A relationship that is below 60% should be rejected. But a relationship between 60 and 80, you accept at your own risk. But kama imepita 80, you una accept straight. So what we can say for this one, we will say accept. Even this one, we will say accept. But this one, we will say reject. We will say reject. Now, closely related to this is R. And you know R is the square root. It's the square root of this. It's the square root of this. But when you are interpreting a report, you are not supposed to compute anything, not unless you have been advised to compute. But because I'm teaching now, let's compute. But kama ni kwa exam, you don't compute. Because unaona kwa hii swali hawajakupea the values of R. So hiyo unaachana nayo. And I think that is the best thing. Let me do that. Let me do that. So R, we will not comment about it because it is not there. Let me just do the way you should do in the exam. So we will not comment about R because it is not present in our case. The next one that we are supposed to talk about is SE, the standard error of estimate. The standard error of estimate. Now, this question has not given us the standard error of estimate, SE. We have not been given the standard error of estimate. So after here, you don't comment about it. The next one that you are supposed to comment about is F. Is F tests. So again, when you look at these results, hakuna mahali tumepewa F tests. So we will not comment about F. We will not comment about F. The next one that you are supposed to comment about is SB, the standard error for the slope. So the standard errors we are given. Kwa equation 1, check whether you can see 0.014. That is the standard error. Hii ingine 0.07007. Na huyu mwingine ni 0.011. So this one, you can say it is the highest. This is the highest. This is the lowest. And this is the medium. Those are the comments you can make about that. This one is the highest. This is the lowest. This is the medium. The next one is the t-test. So before I forget, now that we have not commented on these ones, you make sure you go check your notes after this lesson, go refresh what this means and how they are tested. The last one, before nimesema there are 6, mentioned about 5. The last one inaitwa t-test. Inaitwa t-test. T-test. Now, in t-test, which tests the significance of the relationship, there are 2 things that you need. One is t calculated. And t calculated is given as B out of SB. T calculated is given as B out of SB. So for the first equation, B is 0.054 and the SB is 0.014. Give me the answer. Give me the answer to that. The slope divided by the standard error. Three points. Give me to 2 decimals. To 2 decimals. Yeah, 3.86. I wanted 2 decimals because it is the one that is given huko mwisho. Naona hapo kumeandikwa t value. That is the one. So I wanted you to see how it's computed in case they have not given you. This other one, you will also say the same, minus 0.031. You divide by 0.007. You should get minus 4.43. Alafu huyu mwingine utasema 0.023. You divide by 0.011. It is 2.09. The next thing that we require is plus or minus t at 1 minus 0.05 out of 2, and the degrees of freedom, they will be, these values are 12. 12 minus 1. So go to your t tables. Go to your t tables. Your t tables will summate this value at t 0.975 and 11 degrees. 12 is the number of observations. There were 12 months. So go to your t tables, will summate this value, but here you create. Waiting for the value from the t tables. You're taking too long. Yeah, Ivan says 2.2. Someone else to confirm so that we proceed. Good. Manuel confirmed. So let's go by that. So sasa hiyo inaandikwa plus or minus 2.2 Hapa uandike plus or minus 2.2, plus or minus 2.2. And then now, based on those two results, you make the comment or the conclusion. And this is how you are supposed to look at it. This is how you are supposed to look at it. Like now, this one, on the lower side is minus 2.2, and on the upper side is positive 2.2. If you are inside here, we say it is insignificant. But kama uko huku, tunasema significant, ama huku, significant. These ones, we have the minus and we have the positive. So sasa utakuwa unaangalia hii iko wapi. Kama iko on the lower side ni significant. Ikiwa katikati ni insignificant. Kama iko nje huku juu, it is significant. So tell me, this 3.86, where is it? Or what do we say? Is it significant or insignificant? What do we say? Yes, Evans, good. This one is significant. Significant, good. Use the same knowledge. Uniambie hii nayo. Is it inside or outside? So is it significant or insignificant? Ibrahim says it is insignificant. This is very much significant, Ibrahim. Because you can see here minus 4, itakuwa na huku chini. Minus 4 iko chini kabisa ya minus 2. So it is significant. Ibrahim, good. Even John, you are saying it is insignificant. It is significant because it is on the lower side. I hope Ibrahim and John have gotten that. Is it significant or insignificant? This one? Yeah, good. This one is insignificant. It is insignificant. So going back to the question kidogo, the question ilikuwa imesema we test the goodness of faith, and then we test significance of independent variables. Now, the significance of the independent variables is part of goodness of faith. That's why nimejibu pamoja. The t-test. So Roman 3 is this one. So that is already answered. And you can see the reason as why I have computed, and I had said you should not compute, is because you can see opportunity to maybe I use 95% where applicable. So that suggests we should compute. That means we have the permission. The last one, specifications, analysis, criteria. Specifications, analysis, criteria. That's the last test. Specifications, analysis, criteria. Specifications, analysis. Now, the specifications, analysis, criteria. Specifications, analysis, criteria. It is what in our notes I told you is called assumptions. So the specifications. Remember, an assumption is a condition, and a condition is the other specification. So you are supposed to test 6 assumptions. There are 6 assumptions. So the first assumption is called linearity. Is called linearity. That's the first assumption. And this one is simply tested by either plotting the data. Now here they have not given us the graph, and I have said you should not work out, so we should not draw the graph. So we are not able to test using that method. The second method of testing linearity is developing the equation. and judging whether the equation that you have gotten conforms with the general form of y is equals to a plus bx. So do you think this one conforms to that format of y is equals to a plus bx? This one, does it agree? What do you think? Yeah, good. So if it agrees, then you say it is linear. Here you say it is also linear. And even here you say it is linear. All these are linear functions. It's as simple as that. It's as simple as that. The second assumption is what we call the zero mean. The zero mean. So zero mean of the error terms, the question has not computed the mean for the errors. So we will not comment about it. We do not have it. The third assumption is what we call constant variance. Constant variance. So for the constant variance, again, the question has not given us the errors, the column of the errors. So we will not be able to comment about it. The next one is normality. The next one is normality. Normality is also in regard to the errors. And the question at hand has not given us the column for the errors. So we cannot again comment on that. The next assumption is independence of dependent variable. Independence of dependent variable. And this one we said it is tested using Durbin-Watson statistic. Durbin-Watson statistic. So DWS here in the first equation, the DWS in the first equation is 1.61. Upper DWS is 1.72, and DWS is 2.34. It is tested using Durbin-Watson statistic. Durbin-Watson statistic. So I told you if the calculated is between 0 and 4, between 0 and 4, it means there is independence. There is no autocorrelation. So sasa hapa utasema no autocorrelation. No autocorrelation. Here, no autocorrelation, because we are still between 0 and 4. And here, no autocorrelation. No autocorrelation. And the last assumption is independence of independent variables. Independence of independent variables. So this one is not applicable. It's not applicable here also. It's not applicable because huwa inatumika where you have more than one. Where you have more than one independent variables. And you can see all these ones, just one. In the next question, I will make a small comment about this because it has something similar. But now for the regression and the reliability tests, I think I've given you a quick recap. So make sure after this you go through the topic, and also look at the ANOVA. I've not been able to get an over, to get time to do an over, although these things are still in their ANOVA. They're still in their ANOVA. So look at that. If you are okay with that, tell me proceed so that I go to the next question. Kama uko na swali ulize. Yeah, okay, let me proceed. Yeah, good, good. Can see many people saying we proceed. Career, the next question. So I can see I'm told to proceed. Now that question that is there, that follows, it is already in your notes. I used it. I think I used it in some of the illustrations, but I just thought I bring it back to remind you of just one thing. That question is already in your notes. I don't know whether I solved in class or I gave you as an assignment. The question of December 04. Question number 1. The question focuses on forecasting methods. Forecasting methods. So I will not read all those details. I will just be pointing what is required. So my interest in that question, is more on what we call accounts analysis method. Accounts analysis method. So in the accounts analysis method, I told you what you do. You classify the costs. So we have the cost item. Then the fixed inawekwa hapa. And then you have the variable here. In the accounts analysis method. So looking at the table that is given there, the first one is indirect materials. Indirect materials. Under normal circumstances, any indirect cost is fixed and any direct cost is variable. But this examiner has already guided us. So you go by the guidance of the examiner. Although we know they're supposed to be fixed, the examiner anasema it is variable. So you put it at a variable. So unaweka that 7,500. Then you go to indirect labor. Indirect labor, the amount that is fixed is 171,000. Subtract 171 from 194, ulitumie the balance. Uking'oa hiyo 171 from 194, 200. Send me the balance quickly. 23,200. Good. So that is the variable component. Rent, that one we know so well, is supposed to be fixed. And that is what even the examiner is saying. 236,420. Electricity, that one we may need to be guided. But if we were not guided, this one we should call it fixed. But now they have told us to take it to be variable. 27,210. Depreciation, that one we know it is supposed to be fixed. And that is also what the examiner is saying. 181,000. Then we have maintenance. Maintenance, we also know it should be fixed. But the examiner tells us 8,500 is fixed. The balance is variable. So give me the balance from 24,330. Give me the balance. $15,830. Good. We go to taxes. We go to taxes. So taxes, we are told 6350 are fixed. So give me the balance. Make sure as many are sending the figures. 4870. 4870. Then data processing, we are told I think there is a typo. There is a typo there. There's an amount that is missing. So the one that is fixed is 94.70. Then give me the balance. Give me the balance after that. The other one you're saying for no, not 48. From 16,940. 74.70. Are those things matching well? I'm a typo. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then that 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, typo ndio iko na shida. Let's hakikisha tumefanya vizuri. Let's hakikisha tumefanya vizuri. So hii technical support ndio iko na 16. Data ndio ya 11. Try to match. Aya. Hii ya maintenance tulifaa kusema 24,330 minus 8,500. Hiyo iko sawa. Haya. Taxes tulifaa kusema 6350 minus 14,100. So wacha turekebisha hapo. The typo inaonekana I was doing that thing in a hurry. Haikuingia vizuri. I hope you have been able to understand what I'm saying. So this one should be 7750. Then for data ikiwa na 9470, unastahili kuchukua nao 11,220 minus 9470, 1750. 1750. Then technical, the whole of technical is fixed 16,940. Yeah, that's how it should be. Hizo zenye ziliruka hapo chini ndio zimeharibu the lining. That is good. Umeelewa? Now quickly give me these figures. Total 77, 50 plus 15, 830 plus 27, 210 plus 23, 200 plus 37, 500. So here I'm getting 113,240. Now huyu mwingine 171,000 plus 236, 420 plus 181,000 plus 8,500 plus 6,350 plus 9,470 plus 16,940 is equals to 629,680. Are you agreeing with those figures? Are you agreeing with those results? Yeah, good. So if you are agreeing, the next thing that you do quickly is B. B, you take this variable 113,240. You divide by the question or the data related to 800,000 units. So you divide by 800. You divide by 800. So give me the answer to 3 decimals. Give me the answer to 3 decimals. 113,240 divided by 800. 141.55. And therefore the function would be y is equals to 629, 680 plus 141.55 x. Okay, so I think we have done that. We are okay. Let us now proceed to part B of the question. Use the high row method to estimate the cost of 800,000 units of production expected in the coming period. The high row method. High row method. Hii tulikuwa nayo jana tukasema you have a plus bx is equals to y is equals to y. So this one, you go to the information that is provided in number 3, information number 3. I want you to look at the units and you pick the highest. Pick the highest number of units there. The highest number of units inapatikana as 93. No, not 93. There is a 98. 98. So your 98, I hope you can see it. Tutasema A plus 98,000 B. The cost of that 98 is 777,640. And this is the highest. I hope you have seen that. Then the lowest. After the lowest is 56,900. So A plus 56,900 B. The cost ya huyo ni 717,670. This is the lowest. And something that I emphasized so much the other day is that when you go selecting the highest and the lowest, we only select in the column of units, the X, not in the column of the rows, of the cost. So the cost that you pick is the cost of this highest and the cost of this lowest. So they need not be the highest or the lowest costs. So with that, we now start to solve. So when you subtract those two equations, utasema 98,000 minus 56,900 is 41,100 B. Alafu huyu mwingine atakuwa 77,640 minus 17,670 is 59,970. And based on that, you divide to get B as 1.459. You get B to be 1.459. Then you say A plus 98,000 times 1.459 is equals to 777,640. So based on that, I would say 777,640 minus 98,000 times. I'm getting 634,658. So the function is y is equals to 658 plus 1.459x. So when x is 800,000 units, y predicted should be 634,658 plus 1.459 times 800. Remember the equation is in thousands. Send me the answer. Me the answer. Yeah, I can see 635, 825.2. So something else that I wanted you to capture there is you can see these ones are 800,000, but if you put up at 800, because these figures tumetumia hapa, they were in thousands. These figures were in thousands. The next method we are told to use simple linear regression. Simple linear regression. Simple linear regression method. So here you are supposed to develop the equation y is equals to a plus bx. Y is equals to a plus bx for the overhead cost and the units. But we are already told the results, we are already given the results. We are already given the results that y is equals to, look at information 5. Y is equals to 626, 547 plus 1.504x. Remember, y there is representing the overheads and x is representing the units. It's representing the units. So when x again is 800,000 units, y should be equal to 626, 547 plus 1.504 times 800. So send me the answer. I'm intending to finish this class exactly at 8 so that I can see how far I can go with 2 hours. So in case you have to leave, you don't have to worry much, because after all, maybe by evening we will send the recorded version, so you'll catch up with what you could miss. Okay, give me the answer. Oh, ndio hiyo imekuja 627 750. 627 750.2. So what I would like you to remember, is how to compute B and how to compute A. Those formulas of computing B and computing A, you should be very conversant with them. Using multiple regression results. So let's look at multiple regression. Multiple regression. Multiple regression. This is what we call multivariate regression method. Already the question has given us the results. The results, so you don't have to develop because they have already given us. The results are according to information 6. Ukiangalia hapo kwa information 6, you can see 632, 640, plus 1.501x, we will call it x1, minus 59.067x2. So when X1 is 800,000 units, X2, that is the index. I'm getting the index from, look at information 2. Information 2 inasema, for cost estimation purpose, it is estimated that the coming period's value index will be the same as that of last period, which is 113. So that is the index. Remember, this is the index. So then, Y predicted, the overhead predicted should be 6.2640 plus 1.501 times 800 minus 59.067 times 113. So send me that answer. $627,166. $627,166.229. 627,166.229. That is the answer. And finally, you are told to comment on the most appropriate. So when I taught you these methods, I told you the most accurate is this one. This is the most accurate because it considers several variables. Considers several variables. So make sure you are comfortable with those forecasting methods, account analysis, IRO, simple linear, multiple regression. The next question is a question of July 2000. Question 3B. A manufacturer produces and sells two products, A and B. The unit variable cost is shillings 12 and shillings 8 for A and B respectively. A review of selling prices is in progress, and it has been estimated that for each product, an increase in the selling price would result in a fall in demand. That should be an increase in a fall of demand of 500 units per every shillings 1 increase in price, and similarly, a decrease of shillings 1 in price would result in an increase in demand of 500 units. The current sales prices and sales demands are, we are given that. Okay, let's turn back quickly to page 4. Hiyo swali tumemaliza. I've remembered I was to mention something. Page 4, information number 6. In the table that is inserted there on page on information 6, you can see the correlation matrix. The correlation matrix. Now that correlation matrix is the one we use to test independence of the independent variables assumption. Ile assumption tulikuwa nayo hapa number 6. Independence of the independent variables assumption. And what you simply look at, if you can see that matrix, is the intersection between production and index. So what is the element? What is the element? Put it to me what you can see. The element between those two. Said what you can see. Yes, good. Minus 0.087. So that shows that the two items are not collinear. They are said to be if you get more than 0.8. But you can see now this one is way below. It is something very small. It's not even 0.1. That's the comment that I wanted to make. So as you check your notes, you revise that. So quickly looking at the next question. This question of July 2000, question 3B. July 2000, question 3B. I wanted to use it to remind you about microeconomic pricing method. That is the simple thing that I wanted to remind you. Macroeconomic pricing method. Now, in this one, it is something very simple that I wanted you to remember, that the format is given as P is equals to A minus BQ. That is the format. So once you have that, let's start with the product A. Let us begin with product A. When we go to product A, I have the price of 30 is equals to A minus 15,000 B. Then we are told, if you change the price by 1 shilling, demand will change by 500. So let's reduce this to 29. So if we reduce to 29, because you can see the relationship is inverse, when you reduce the price, demand goes up. So we are going to have minus 15,500 B. That's the first thing. Demand will go up. So let's try to solve this. Now, trying to solve this, you subtract, and you get 1 is equals to 500 B. So based on that, you should be able to tell me that B is 0.002. 0.002. Okay, so if that is the case, we proceed and say 30 is equals to A minus 15,000 times 0.002. So based on that, I should be able to say 15,000 times 0.002 plus 30 is 60. So A is 60. So thus, the price should be equal to 60 minus 0.002 Q. That is the price of A. That is the price. So if they ask you to get the revenue, you will say it is 60 minus 0.002 Q. Now this one, you multiply by Q. And this one will be 60 Q minus 0.002 Q squared. Then, if you are told to get marginal revenue, you just differentiate this to get 60 minus 0.004 Q. So for maximum revenue, marginal revenue should always be equal to 0. That is 60 minus 0.004 Q should be 0. And based on that, I get Q should be 15,000. So at this point, if they ask you the price, sasa unakuja hii umepata, you substitute in this one, unasema 60 minus 0.002 times 15,000 is equals to 30. And revenue should be 30 times 15,000 units. That is 450,000. And you see this one has gone back to where we began. It is only a coincidence. It's not a math that we shall always go there. So you have been asked to compute maximum revenue. That is what you say. The last thing I want to remind you is that for maximum profit, marginal revenue should be equal to marginal costs, which is also equal to variable costs, That is 60 minus 0.004 Q. The marginal cost of A is 12. So that means Q should be 60 minus 12 is 48. You divide by 0.004 is 12,000 units. So at this point, P, you now substitute again in the price function, 60 minus 0.002 times 12,000. So is that 6? So kama umeulizwa profit and you have the equation for the profit, you now substitute and get the profit. So I would like you now on your own, you do the same for product B. On your own, you do the same for product B. And that brings us to the end of our today's lesson. So attempt these questions that are remaining there. I hope we shall be able to finish them in the next lesson. If not, we shall see what to do, whether we need an extra lesson. I might have recorded them elsewhere. So we call it a day at that juncture. Thank you so much. Have you finished copying? You are finished, say my yes, so that I end the lesson. As you finish, you also exit so that I'm also able to keep track of who is remaining, so that I don't end before everyone has copied. So as you finish, you exit.